Hello, and we are going to talk about LINQ majorly, but then LINQ requires certain features. So, how do we deal with these features first is what we'll learn, and then we will switch our context to something called LINQ. So, features which we are going to go and discuss in the in this session. So, first feature we are going to go and discuss is implicit type. Then we'll be discussing about object initializer. Then we'll be discussing about anonymous type. Then we'll discuss about extension method. And then finally, we'll talk about Lambda expression. And in the meantime, we'll also talk about something called new delegates like func and action. And this is what becomes basis for learning LINQ. So this is what our agenda is. So we'll start with first one, implicit type. So let's create a new project which would be console application. Let's try to store our project somewhere on E drive. And I'll be creating this console application as test features. So to start with, what is implicit type? So normally, if you see, if I have integer I equal to 100, where is the value which gets stored? Does this value get stored over stack, or does this value get stored over heap? That's the question. So if at all the value gets stored on top of a stack, suppose, then suppose if I go for creating one class, public class, let's say EMP. Let's try to create few properties here, maybe with integer number and string name. And let's have one method as well. Let's not have a method. These are the two properties that we have got, which will actually manipulate number and name private members. So if I create employee class object, employee emp equal to new employee. So point to note, this value, first one, is going to go over stack. This value is going to go over heap because employee size can grow as per the demand, and then when it comes to stack also, integer I, then the value is almost fixed with a 32-bit as a final size, no matter what we provide within the range of integer any value on the right hand side. So now we all know one universal type in case of .NET, which is actually called as object. Now if at all I put object obj equal to I out here, then where exactly I gets stored now? So you wrapped up I so that which is actually on stack and which gets stored now, or which gets stored, which gets wrapped into some heap type which is called as object. And generally what we call this is as boxing. Same way, suppose if I put object obj2 is equal to emp, what you have done again, emp was already there on top of heap, you try to wrap it and You try to store it or point it with the help of obj2. Ultimately, object itself is a heap type. So whatever is on heap remains on heap. But here, in the first case, whatever was there on stack, you wrapped it into something which actually resides on heap. So then this is normal. The second case is normally casting for us. Now, this is very routine development scenario that we do it. But if at all, if we take a scenario now, suppose integer j is equal to obj, if we put up, then obviously since object is a universal type in .NET, we don't know what is getting stored inside object now. So what happens now is the blind conversion is not going to happen automatically. So then if we know that it is integer, it is our job to convert this into integer. And then now the type again hops from heap to stack, and this is normally called as unboxing. And similar way, if at all I have to hold it like emp ref, then you have to, again, you can't just blindly transfer it. You have to convert it by yourself as employee. And this is normally known as unboxing. This is pretty simple, and I guess everybody knows over here what these two concepts are. But then what is it that we are trying to prove over here? What we're trying to prove is if at all we use object as a type, then guaranteed either boxing is going to go and happen or casting is going to go and happen. So if at all we go for something called as boxing or casting, then that is always going to go and reduce the performance. It's always going to cost CLR some CPU cycles to get this job done. Then what's the solution? So let's comment this. I'll put this in the region now. Maybe let's say old problem. I'll name it as. Now, how do I solve the problem? So if at all you don't know what's on the right hand side of equal to, and if you try to store it in case of object type, then either boxing or casting is bound to happen. Now let's solve the problem. How? So C# 3.0 announced a concept which is called as implicit type, which is var. So if at all we put up now var v is equal to suppose 100. So based on what is on the right hand side of equal to, this evaluation happens at compile time, and then v actually gets type automatically. So if I carry a cursor on var, Visual Studio courtesy, it shows you that what v stands for. And as you can see here, v stands for an integer. If you wish to print type of v right now, so let's say get type and dot to string, and if you try to run the program, you will notice that v actually stands for integer, which is amazing. If at all you put var v1 equal to new employee here, and if at all on the console again, if you put v1 dot get type dot to string, rather if you would have noticed this, when I said v1 dot, you also get something called as number and name automatically, which means v1 actually acts as an object of which type? Employee type right now. So this is very important point to note. So if at all you see v right hand side 100, v becomes integer, which means over stack it resides. If at all I see v1 right hand side is new emp, which is actually over heap, then v1 becomes heap type called as emp now. So had it been object over here and here a boxing would have happened and here casting would have happened. So if you notice very clearly, we have just avoided boxing and casting just now. And that's the important point to note about var as a type. But then there are certain drawbacks as well. I won't say drawback, rather limitations of var as a type. When shall I use this var type? You should use var type whenever you don't know what is on the right hand side of equal to. Now that's a complete imaginary scenario. You always know what is on the right hand side of equal to. Maybe on the right hand side of equal to you have got 100.22. If at all it's 100.22, you always know that you are bound to store that maybe in some sort of double type. So if at all, let's say on the right hand side you have some function call and the function is going to go and return you something. If the function is going to go and return you something, using documentation, you already know what the function is going to go and return you. Maybe the function returns you object type. If the function returns object type, then var becomes object type. So there is no such situation which exists wherein you actually don't know what is on the right hand side of equal to. So far you survived by even not knowing by always knowing what is on the right hand side of equal to. So such situation is very imaginary. But then will we have some kind of a situation like I don't know what's on the right hand side of equal to? Will we have it? Yes. And for that, we'll have to learn a couple of other features, which means we have a solution to a problem which we are yet to discuss. So this is one part wherein maybe let's say implicit type can be used for when I don't know what's on the right hand side of equal to, we'll use var type. But then there is also one more limitation, and the limitation is if I put this var type at the class level, where suppose v is equal to 100, and if you compile the code, you normally end up in an error that the keyword var may only appear within local declaration, which means var is always and always a local scope variable. It cannot just go to class level or global level at all. If at all you define some function into the code, suppose public void some function if I create, and if at all you try to pass on parameter called as var and v, again if you compile you will end up in the same sort of error, that is var may only appear within local declaration only, which means var cannot be passed as a parameter, var cannot be returned as a parameter, and var cannot be declared at a global level or class level. It can only between the curly brackets of a function only, and that actually is a very major limitation of implicit type called as var. So there's one good point that it automatically takes the content, analyzes the content, and then compiler is going to go and assign that over stack or heap. Limitation is it is always and always a local scope, and it is always and always can be used only in local scope, cannot be passed as a parameter, cannot be returned even from the function itself. So this brings us to conclude something called as implicit type in .NET. So I'm going to again surround this with region and let's name this as implicit type in .NET.